So welcome everybody to this latest video on 162 Math, and in this video we'll be going over another practice paper in the high syllabus, but this time we're looking at set 1 paper 2, which is a calculator paper. Now there will be a copy of the paper in the description below, which I strongly recommend that you have an attempt at before watching this video and going through the answers, and I'll also include the grade boundaries as well, which is going to be suggested as this isn't a real paper. So let's get started on this AQA GCSE Maths higher practice paper set 1 paper 2, which is a calculator paper. So looking at our first question, it says which of these is used to work out density? Well, it's a case of remembering that density is mass over volume, and so it is our third option. Then looking at question 2, it says circle the fraction equivalent to 2.375. Well, for this one, all you need to do is to simply type these fractions into your calculator, press your SD button. So for example, just work that out, do 9 over 4 equals 19 divided by 8 and 75 divided by 23, and you're looking for which one gives you an answer of 2.375. Well, it's going to be our third option. Then moving on to question 3, it says circle the equation of the x-axis, and that is going to be y equals 0. And for question 4, it says the angles of a quadrilateral are 140, 80, 60 and 80. What type of quadrilateral could it be? Well, I would recommend that you actually draw the shapes out and then just try and match them up, but basically the correct answer is going to be a kite. So moving on to question 5, it says that a solid cuboid is made from centimeter cubes. The plan view, front elevation and side elevation are shown. It says how many centimeter cubes were used to make the cuboid. So all you need to do here is pick out the dimensions. So here this is going to be 4 by 6. I've got 4 by 3 and 3 by 6. So the dimensions are going to be 3 by 4 by 6. And if you type that all into your calculator or work it out, you should have an answer of 72. Then with question 6, it says the times are that 80 customers waited at a supermarket checkout are shown. And it says in which class interval is the median? Well, if we've got 80 customers, if we divide that by 2, the median customer will be the 40th person, and that person will be in this group here, which is where T is 2, between 2 and 4, inclusive of 2, exclusive of 4. Then with question 6b, it says the manager of the supermarket says that 90% of the customers wait less than 6 minutes, and says does the data support the statement? So for this, if I just zoom out a little bit, so here if we did 90% of 80, which are the customers, then that equals 72 customers. Now if we looked at how many customers were waiting for 6 or less than 6, well, that's going to be 32 plus 19 plus 20. So here we've got 32 plus 19 plus 20, which equals 71 customers. So therefore the question is no. Even though it's very, very close, it's still a no. It's just less than 90%. So moving on to question 7, it says 50 people took a test. It says before the test they predicted whether they would pass or fail. 30 people I should say, predicted they would pass. 36 people did pass, and of these 36 people, 3 times as many predicted pass as predicted fail. Now in terms of this question, what we need to do first is, well, we know that 30 people would pass. So looking at this key bit of information, so we know that this number here is going to be 30, and if that's 30, this is going to be 20. Now we then need to work out, well, from 36 people did pass, so this number here plus this number here needs to add up to 36. Now of these 36, it says 3 times as many predicted pass as predicted fail. So here what we've got is we've got a ratio of 3 to 1, where we've got a pass and we've got fail pass, and we've got 36 to share. So if I did 36 divided by 4 gives me 9, and then from this I multiply that by 9 and this by 9, in which I get 27 and 9. So this is going to be 27 and this is going to be 9, and from those values I can then work out what the fail amount is going to be. So this is going to be 3 and this is going to be 11. Then moving on to question 8, it says that Thomas ran a lucky dip stall, and we've got tickets ending in 00 win £12, tickets ending in a 5 win £1.50, and tickets cost 50 pence. It says there were 750 tickets numbered 1 to 750. Thomas sold all the tickets, all the winning tickets, and some of the losing tickets. He made a profit of £163, and the question is asking how many losing tickets were there. Now this one is going to be a little bit long-winded, particularly as it's worth 6 marks. So let's have a look at working this out. So the first thing we need to do is, first of all, find out the number of tickets ending in 00. Now that's going to be 100, 200, 300, 400, 500, 600, 700. So there are 7 tickets. So that means then that the prize money is going to be 7 times 12, which is £84. And we'll come back to that £84. So then the next thing we look at is the number of tickets ending in a 5, and that's going to be 75. So it's going to be 75 tickets. So then if we then do the prize money for that, which is going to be 75 times £1.50, which gives me an answer of £112.50. Then what we then need to do is look at the money raised. So the money raised, well, that's going to be the profit that is collected, which is £163, plus the prize money for the top prize, which is 84, plus the total prize money for second prize, and that comes up to a total of £359.50. So then from this, what we can then do is work out what the total number of tickets sold. So total number of tickets sold, which is going to be 359.50 divided by the cost of one ticket, which is 50 pence, and that comes up to a total of 719 tickets. Now that's not the final answer, because obviously all the winning tickets were sold. So what we then need to do, so the losing tickets is going to be 719 minus the number of winning tickets. So it's 719, take away 7, take away 75, which gives me a total of 637. Now for the next question, question 9, it says write 280 as a product of their prime factors. Now if you've got a Casio calculator, all you need to do here is press 280, then press equals, and then press shift and fact, which is a scientific button on your calculator. But if you haven't got that, then all we need to do is draw our factor tree. Now your factor tree might be completely different to mine, in which remember that when you're doing a factor tree, you just circle, think of two numbers that multiply to give you the number above, but circle any prime numbers. So I've got 70 and 2, 35 and 2, and then 5 and 7. And so the answer for this then is 2 times 2 times 2 times 5 times 7, or I can write it as 2 cubed times 5 times 7, and that would be fine. I think you'd get answers for both because it doesn't say to give your answer in index form or using powers. For question 10, it says expand and simplify. So all we need to do here is just use our brackets. And so here we've got y squared minus 4y plus 5y minus 20. And that simplifies to give me y squared plus y minus 20. Moving on to question 11, it says work out the size of angle x. So for this, what we need to do is use a bit of trig. Now you could use Pythagoras to work out what this length here is going to be, which I'm going to call O, but again, totally unnecessary. So if we just label the sides that we do know, and so long as your answer is correct, then that is going to be absolutely fine. So I've got A and H, so I'm going to use cos. So I've got cos x equals adjacent over hypotenuse, so it's going to be 8 over 11. So I've got cos, inverse cos of 8 over 11 equals x, and that should give me an answer of around about 43.3 to 1 decimal place. Then moving on to question 11b, it says work out the length of y. So again, labeling the triangle, remember that this is the opposite, that's theta, and that's the adjacent. So this time I'm going to use tan. So here I've got tan 40 equals y over 37. So y equals 37 times tan 40, and that should give me an answer roughly around 31. Then looking at question 12, it says that a water tank is a cylinder with radius of 40 centimeters and depth of 150 centimeters. It is filled at a rate of 0.2 liters per second. 1 liter is 1,000 centimeter cubes. Does it take longer than 1 hour to fill the tank? So I'm going to do the working out on the screen here. So the volume of the cylinder is going to be equal to pi r squared h. So substituting those numbers in, what do I get? Well, I'm going to get 40 squared times pi times 150. And that gives me an answer of 753,982 centimeter cubed. Now from this, what I then want to do is I want to convert that into litres. So then if I divide that by 1000, then what I get is I'm going to get 753.982 litres. And then from there, what I then want to do is work out the rate of how many will pour in 1 hour. So in 1 hour, I'm going to get 0.2 litres per second. So times that by 60 to work it out per minute, and then times another 60 to get an hour. And that gives me an answer of 720 litres in 1 hour. So is it going to take longer than an hour? Yes, it will take longer than 1 hour. And again, if you want to show a little bit of working out in terms of proof, you could say that 753.982 is greater than 720. But again, I think that there's enough working out there in maths for you to get those 4 marks. So looking at question 13, it says that x multiplied by x plus 4 is an identity to x squared plus 4x. It says for how many values of x is x and multiplied by x plus 4 equal to x squared plus 4x. Well, for this, it's going to be valid for all values. So not just a few, but for all of them. That's usually what identities imply. So for the next question, it then says, for question 14, it says that Sophie sells birthday cards. She adds 30% profit to the cost price. She sells the cards for £2.34 each. She wants to increase her profit by 40% of the cost price. How much should she sell each card for? Now for this, again, what we need to do first is we need to work out what her original cost price is. So we need to work that out. So the cost price. Now to do this, what we need to do is we know that £2.34 is 130% profit, because obviously 100% is the cost price, 30% is making on top of that. So if we divide this by 1.3, then what we get is that the cost price is £1.80. Now she wants to make 40% profit. So in terms of that, what we then need to do is £1.80 times 1.4, and that gives me an answer of £2.52. So that's how much Sophie needs to sell those birthday cards for. For the next question, question 15, it says write down a possible set of values for A, B and C. So looking at 6006.6, well that's 6000 plus 6 plus 0.6. Now if I convert each of these numbers into standard form, well that's 6 times 10 to the 3. That's 6 times 10 to the 0, and this is going to be 6 times 10 to the power of minus 1. And these values here are my A, B and C. So that's going to be 3, that's going to be 0, and that's going to be minus 1. For question 16, it says work out the equation of the line that is parallel to the line y equals 5x minus 3 and passes through minus 2, minus 4. Now, several ways in which you can do this depending on how you've been taught the equations of a line, but I'm going to go for probably the most common, which is using y equals mx plus c. Now, in terms of the gradient, we know it's parallel, so m equals 5. And what we then need to do is we're going to use these two values as my values for x and y. I don't know why I've put a y there, so that one's y. And we're going to try and find c. So what we've got so far is we've got that minus 4 equals m which is 5, times x, which is minus 2, plus c. So I've got minus 4 equals minus 10 plus c. Take the 10 over and we get 6 equals c. So then substituting these numbers into that formula, I get y equals 5x plus 6. Then moving on to question 17, it says that Joe asks 230 students how long it took them to travel to school, and we've got a table, and it says that this is Joe's attempt to draw a histogram to show the data. And the question is asking us to make 2 criticisms of the histogram. Now for this, there's a couple of things we could write because it is a complete utter sham of a histogram. But basically, one could be that the bars shouldn't be equal width. Otherwise, you just draw a bar chart. You can also add the fact that the horizontal axis is incorrect. Axis is wrong. And our second criticism is that the frequency density is not used. And that's something that should be used along the vertical axis, should be used on the vertical axis. Instead, what he's done is just use the frequency. You could also say that the heights are wrong as well, the bars. And there we go. So moving on to our next question, question 18, it says that the table shows the running times of some films, and it says draw a cumulative frequency diagram on the grid opposite to represent the data. So first of all, what we need to do is work out the cumulative frequency values. So this is just going to be a running total, in which all you're doing is just adding the previous frequency to the total, in which we should have these values. Now when it comes to plotting, you need to remember that we're going to plot the upper values against the cumulative frequency numbers. So from this, and again I might have to switch between the two because obviously my eyesight in terms of the screen is not great. So at 80 it's at 0, at 100 it is at 9, which is about there. At 120 it's at 44, which is there, and 74, which is at 140, and that's going to be about there. And at 160 it is at 92, which is just there, and at 180 it's at the grand total of 100. Now what we need to do now is join those points up as best that we can. Hopefully yours is going to be a lot more accurate than mine, and what we should have is something that looks like this. Now don't worry if you haven't drawn the line going from 8 to 60 because it's just at 0, but that's basically what we should have. Now for the next question, it then says estimate the number of these films with a running time of less than 2.5 hours. Well, 2.5 hours is going to be 120 plus 30, which is 150 minutes. So what we need to do is find where 150 minutes is, which is just about there, and we draw our vertical line at that point. Again, you should be using a ruler, and as soon as it hits the cumulative frequency curve, we then want to project across, in which we should get something that looks like there. Now it's say an answer roughly around 82, but as long as you can show the evidence on your cumulative frequency diagram, you should get the 1 mark at that, particularly if you've done it at 150. I'd say, to be fair, that question's a little bit stingy. So moving on to question 19, which looks at direct and indirect proportion. It says that W is directly proportional to Y. W is inversely proportional to x squared. When y equals 4, w equals 14. Work out the value of w when y equals 9, and it's worth 2 marks. So first thing we need to do here is first of all work out the formula. So here we've got y is proportional to w is proportional to y, and then so we then replace the proportional symbol with equals k. Then we substitute the numbers in to work out what k is. So I've got 14 equals 4k. So then k equals 14 over 4, which is 7 over 2, which is 3.5. So the formula then is that W equals 3.5 y, and then we substitute the numbers in, so W equals 3.5 times 9, which gives me an answer of 31.5. Then for question 19b, it says when x equals 2, W equals 5, work out the value of W when x equals 10. Now for this, what we need to do is, we know that W is proportional to 1 over x squared. So then we replace the proportional symbol with equals k. We then substitute the numbers that we know, which is 2 and 5. So what we've got is we've got 5 equals k over 2 squared. And let's just move this up over here. So I've got 5 equals k over 4, so k equals 20. And then looking at the formula, I've got W equals 20 over x squared. And that's the formula that I've got to use. So W equals 20 over 10 squared, which is 100. And that gives me an answer of 0.2. Then looking at 19c, it says which graph shows the relationship between y and x. Now for this, what we need to do first is see the relationship. So I've got W equals 3.5y, and I know that W equals 20 over x squared. So if I make the two things equal to each other, because they're both equal to W rather, so I've got this. Then making y the subject, I get y equals, and it's going to be 20 over 3.5x squared. Now basically what I'm looking for is a graph that resembles this. Okay, and which value is that going to give me? Well, it's going to give me the answer of D. It's probably a long-winded way of working it out, but so looking at question 20, which looks at the iterative process, it says that an iterative process can be used to find the approximate solutions of x cubed plus 5x minus 8 equals 0, and we've got a number of steps that we need to then follow. So question 20a says use the iterative process to find the solution to 4 decimal places of x cubed plus 5x minus 8 equals 0. Start with the values of x equals 1. So for this, what we need to do is substitute the x value into this formula here. So what we've got to find the second value, so the first value is 1. So for the second value, what I've got is I've got 2, 1 cubed minus 8 over 3, 1 squared plus 5, and that gives me an answer of 1.25. I then, for the third value, do 2, and then this time I'm going to use a previous answer, which is 1.25 cubed minus 8 all over 3 lots of 1.25 squared plus 5, and that gives me an answer of 1.229. And again, looking at the next one with the fourth value, I get 1.2289, and then for the fifth value I get 1.2289, and that's where it starts to stabilize to 4 decimal places. So the answer then is 1.2289. Now if you did use the calculator to do this, if you just press 1 and then press equals, and then for the next one just press 2 ands cubed minus 8 over 3 and in brackets squared plus 5, and then just press equals, and then the first one will give you 1.25, press it again, it will give you this, press it a fourth time, it will give you this, press it a fifth time, it will give you this, until the number stabilizes to 4 decimal places. So for question 20, it says by substituting your answer in part A into x cubed plus 5x minus 8, comment on the accuracy of your answer to x cubed plus 5x minus 8 equals 0. Well, if I substitute it in, so if I do 1.2289 cubed plus 5 lots of 1.2289 minus 8, it gives me an answer of 0.000037, and that is pretty good. That's very close to 0, so it is pretty accurate. So yes, it's a great approximation. So something along those lines would be absolutely fine to get the 2 marks. Moving on to question 21, it says that ABCD is a parallelogram, C to E is equal to C to F. Prove that Y equals X. So We know that ABCD is a parallelogram, which means that opposite angles are going to be equal to each other. So that's going to equal to x. Now in terms of angle C, well, that's going to be 360 minus 90 plus minus 2x. And if I simplify all of that, what do I get? Well, I'm going to get 180 minus 2x. So that's what this angle here is going to be. Now to work out y, well, y is going to be 180 minus, because angles in a triangle out 180. Well, if that angle there is this, then I've got 180 minus or equals 180 minus 2x plus 2 lots of y. Now from this, the 180's cancel, so if I take that over to the other side, then it was 0 equals minus 2x plus 2y. I then take the 2x over to the other side, so I end up with 2x equals 2y. Divide both sides by 2, and I'm left with x equals y, or y equals x, which is what they've wanted me to prove. Moving on to question 22, so this looks at set notation and Venn diagram. So the Venn diagram shows information about coin collection. We know that there's 120 coins in the collection. T represents the coins from the 20th century and B represents the British coins. It says that a coin is chosen at random. It is British. Work out the probability that it is from the 20th century. So from this we know that x multiplied by x minus 5, which is our value of t, plus x minus 2 plus 32 has got to add up to the total number, which is 120. Now if I then go on to expand and simplify that, what I end up with is x squared minus 13x minus 90 equals 0. So it turns to a quadratic. I can factorize that or go on to solve it, but basically using either way, I end up with x equals 18 or minus 5. Now we know that it can't equal minus 5 because, again, we're going to end up with negative numbers and we can't have that. So x must equal 18. So if I then substitute x equals 18 into this, then this becomes 16 and this becomes 18. So all in all, how many British coins have I got? Well, I've got 34 British coins. So from this, how many of those 34 are from the 20th century, and that represents x, so that's going to be 18 over 34, which simplifies to give me 9 over 17. Again, either of those would be absolutely fine. So moving on to question 23, it says that a speed time graph for a car's journey is shown, and what the question is asking is to estimate the acceleration at 6 seconds. Now for this, what we need to do is, at 6 seconds, what we need to do is draw the tangent and work out the gradient. So what we need to do is work out the gradient of the tangent at 6. So from this, what I then need to do is draw a tangent. Now again, everyone's tangent is going to be slightly different, and I think what they're looking for is just the fact that it does touch that point, which again is going to be incredibly difficult on the computer, but hopefully you'll know what we're trying to do. So from this point, what we then need to do is basically kind of just draw a triangle and then look at the distances. So that's going to be 4 and that's going to be 4 as well. So I would give an answer of around about 1 meter per second squared would be our acceleration. Then looking at question 23, it says estimate the average speed of the car of the journey. You must show you're working out. So for this, what we need to do is work out the area under the curve. Now there's several ways in which we can do this. So if I just go back to the graph and let me just get rid of all of that to begin with. Now what I'm going to do is I'm going to split this graph into 3 sections. And I've got section A, which is the triangle, section B, and I've got section C. Now in terms of the shapes, I can work out what the area of A is by using base times height divided by 2. So the base is 24 take away 18, which is 6, times the height, which is 12, divided by 2. So that gives me an answer of 36. I can then work out what the area of B is, because that's a rectangle. So area of B is going to be base times height, which is 4 times 12, which is 48. Now for C, now this is where it gets a little bit more complicated. Now for this, what you want to do is kind of work out what C is. Now you can either treat C as a triangle, like so, and you can work out the base. So the base would be 14, the height would be the height would be 12, and that would be absolutely fine. Or what we could do is treat it like a trapezium, because obviously that's not as accurate. So what I could do is, in terms of this, I could maybe work out what this area here is going to be, and then we then need to work that out. So in terms of area of C, if you treat it like a triangle, then it's going to be 14 times 12 divided by 2 equals, and that's going to give me a total of 84. And if you treat it like a trapezium, then you're looking at 4 plus 12 times 14 divided by 2, which gives me an answer of 112. So you're either going to add 36 plus 48 plus one of those two values, or whatever you've calculated to work out C, whether you've counted little squares or the big squares. Just be careful in terms of that. But in terms of that, there's several answers in which you could get, but I would say that in terms of working those out, let's just go for any of those. So let's go for the trapezium. So using C as a trapezium, we get 36 plus 48 plus 112, which gives me 6 plus 8, 14, plus 2 is 6, and then we've got 7, 8, 186. Meters per second. Then moving on to question 23C, the question is asking us to evaluate your part in B. Now for this, all we need to do is basically just state our statement. So if it's an underestimate, well, I would say, depending on in terms of what you've used, so whether you've used a triangle or used a trapezium, I would say if you've used a trapezium, you have overestimated. If you've used a triangle, you have underestimated. So there's two possible answers you can have. You're definitely not going to have exact, that's without a shadow of a doubt. So if the area of C is under the curve, then it's an underestimate. You just need to make sure that you've ticked that box and the reason for it. And if area C is above the curve, then it's going to be an overestimate. And again, two possible answers depending on what you have calculated for your answer above. And finally, for question 24, it says show that, and we've got here, I'm not going to read that out because it's going to be a big waffle of a situation here. So all we need to do is just simplify this algebraic mess. So what we need to do here is recognize that we can actually simplify each of these expressions, and this and this. So we're going to simplify every single one of these components. And I know I've just destroyed the question, so we can't read it. So let me just get rid of that. So in terms of looking at this first one here, I can factorize that because I've got 2 as a common factor. So I've got 2w plus 2. And from the next one, let's do use a different color. We've noticed that that is a difference of 2 squares, and that factorizes to give me w minus 5, w plus 5. Now the order which I've written that does not make a difference. Then if I look at the top of this one here, that can't be done anything with that, so I'm just going to leave that as times w plus 5, but I will put that in brackets, over, and then if I look at factorizing this, that factorizes to give me w plus 2, w plus 1. And then finally, if I factorize this, I'm going to get 3w minus 1 and w minus 5. Now, what I then want to do is join all of these things together. So on the top, I'm going to have 2w plus 2, w plus 5, and then 3w minus 1, w minus 5, and at the bottom I'm going to end up with w minus 5, w plus 5, W plus 2 and W plus 1. And what I'm then going to do now is cancel everything that's on both top and bottom. So here I can cancel my W minus 5, I can cancel W plus 5, and I can cancel a W plus 2. And so what am I left with? Well, I'm left with two lots of 3W minus 1 over W plus 1, but I want to make it look like this. So here what I've got is I expand the bracket, so I get 6W minus 2 over W plus 1, and there is my final answer and the end of this paper. Now, as I mentioned, this is a practice paper, so there aren't no official grade boundaries, but I will attach some sort of a decent guess on the grade boundaries for this paper. But just bear in mind that as this is a practice paper, as with paper 1, that these questions were a little bit tricky and a little bit more difficult than what you typically expect in your GCSE exam. But again, the questions don't make it paper difficult, you do. It all depends on how much preparation you've got, how much knowledge you've got, and how much understanding you have to make that exam paper easy or difficult.